Before we investigate the announcement, it's fundamental to understand the meaning of what's at stake. The Large Hadron Collider, LHC, operated by CERN, marks a tremendous accomplishment in scientific progress. Spanning 17 miles, this sophisticated array of superconducting magnets stands as the largest and most powerful particle accelerator ever built. It serves as a symbol of human ingenuity and the remarkable achievements we've made in understanding science. Incredibly, the LHC is capable of recreating the conditions that existed at the very beginning of the universe. However, as we venture into the cosmic unknown, a crucial question arises. Could this machine, which aims to uncover the universe's deepest mysteries, also expose us to unforeseen dangers? Founded in 1954, CERN is one of the world's most respected scientific institutions, with 23 member nations and a vast research community. It serves as a center for collaborative research and groundbreaking discoveries. Although the LHC is its flagship project, it is just one part of a vast network of particle accelerators and experiments. Think of it not as a racetrack for cars or horses, but rather as one for subatomic particles, engaged in a high-stakes race to test the limits of speed, precision, and the very fabric of reality. Inside the LHC, protons are accelerated to speeds approaching the speed of light, mimicking the energy levels that existed at the moment of the Big Bang. The resulting collisions generate temperatures far exceeding the core of the Sun. A system of magnets guides the protons along their paths, while advanced cooling systems maintain the magnets at temperatures colder than outer space. These collisions are deliberately orchestrated at 4 specific points within the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb, collect data. Each detector has a unique function, offering different perspectives on the aftermath of these high-energy impacts. Together, they act as enormous cameras, capturing the results of these collisions. Scientists carefully analyze the debris to identify elusive particles like the Higgs boson, often referred to as the God particle, and other phenomena that may reveal the fundamental building blocks of the universe. By focusing on subatomic particles, scientists aim to comprehend the very structure of the cosmos. However, each new discovery at the LHC raises even more questions. The LHC is not just a machine. It represents humanity's unyielding curiosity and relentless pursuit of knowledge. It symbolizes our desire to understand the forces that shape reality. But as we push the boundaries of the unknown, we must confront the ethical and existential dilemmas that come with it. What dangers could arise from exploring the unknown? Could our quest for knowledge unleash forces beyond our control? At CERN, where the limits of human understanding are being tested to their extremes, a troubling realization has emerged, one that has unsettled even the most seasoned scientists. Brian Cox, a former CERN researcher and a highly regarded physicist, recently made a chilling statement that has both fascinated and alarmed people worldwide. Cox revealed that the LHC's purpose is to recreate a miniature version of the Big Bang, essentially a small-scale cosmic explosion. He elaborated on the LHC's immense potential to unlock groundbreaking discoveries, such as solving the mysteries of dark matter, a substance that makes up most of the universe. The possibility of harnessing the fundamental forces of the universe is undeniably exciting, but it also comes with significant risks. The miniature Big Bang is not just a theoretical concept. It is a real phenomenon occurring within the LHC. The collider replicates extreme heat, pressure, and energy conditions, mirroring the environment at the birth of the universe. We may even be witnessing the birth of time itself. However, with such tremendous power comes enormous responsibility. What if something goes wrong? This concern is not new. Back in 1978, Russian physicist Anatoly Bugorsky had an experience that forever altered his life's course. While working with the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused a proton beam to pass through his head. The beam, traveling at incredible speeds, pierced his skull, entering from the back and exiting through his nose. Though struck by a flash of light brighter than 1,000 suns, Vygotsky remained conscious and walked to seek medical attention. The aftermath was both astonishing and horrifying. He lost hearing in one ear and suffered partial facial paralysis. Yet, despite the severity of his injury, his cognitive abilities remained intact, and he continued his scientific work. Vygotsky's experience is a grim reminder of the power and potential dangers associated with particle accelerators. The risks of machines like the LHC should never be underestimated. Some scientists have expressed concerns about the possibility of unforeseen reactions that could alter the very fabric of reality. For instance, there are fears that the LHC could potentially create a tiny black hole. Black holes are regions of space where gravity is so intense that not even light can escape. These cosmic forces exist at the edges of the universe, and the idea that the LHC could create even a microscopic black hole is both awe-inspiring and terrifying. Could such a black hole spiral out of control, eventually consuming the Earth from the inside out? CERN scientists have tried to reassure the public, stating that any black hole formed within the collider would be highly unstable and would disappear almost instantly. Still, the mere possibility of such an event has sparked intense debate and concern. To understand how the LHC could potentially create a black hole, it is essential to grasp the fundamental mechanics of a particle accelerator. When protons collide at near-light speeds, the energy released is so immense that it could distort the very fabric of space and time. To visualize this, imagine a trampoline stretched tightly. If a heavy object is dropped onto it, the fabric bends. If the object is heavy enough, it can create a depression deep enough to pull in surrounding objects. This analogy provides a glimpse into how the LHC could impact space-time at a quantum level where the laws of physics become unpredictable. One theory suggests that extra dimensions beyond our familiar three dimensions of space and one of time might exist. If such extra dimensions do exist, the LHC might have the potential to access them, forming a gravitational well that leads to a tiny black hole. This possibility has caught the attention of renowned physicists, including the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson could become unstable at extreme energy levels, possibly triggering catastrophic events such as vacuum decay. Similarly, Sir Martin Rees, a distinguished astrophysicist, raised alarms about the LHC's experiments. In his book On Humanity's Future, Rees acknowledged that while the probability of such an event was low, even a small chance warranted serious consideration. The stakes are unimaginably high, and the margin for error is razor-thin. CERN researchers have conducted numerous simulations and experiments, taking every precaution to ensure the safety of their tests. Brian Cox himself has addressed concerns surrounding the LHC, emphasizing that strict safety protocols are in place. Despite reassurances from CERN scientists, concerns about the LHC's potential dangers persist. The very nature of scientific discovery means venturing into the unknown, and while rigorous safety measures are in place, the possibility of unforeseen consequences cannot be entirely dismissed. The ethical dilemma: are we playing with fire? The LHC is a testament to human ingenuity, but it also raises profound ethical questions. Throughout history, groundbreaking discoveries have often carried unintended consequences, from nuclear power to artificial intelligence. While these advancements have led to remarkable progress, they have also introduced new existential threats. Some critics argue that our pursuit of ultimate knowledge comes with unquantifiable risks. What if the LHC unlocks forces that humanity is not prepared to control? Could we inadvertently trigger a chain reaction that alters the very laws of physics? One of the most alarming concerns is the theoretical possibility of vacuum decay, a catastrophic event where a high-energy particle interaction could create a true vacuum bubble that expands at the speed of light, annihilating the universe as we know it. While most physicists, including Stephen Hawking, considered this an extremely unlikely scenario, even a 1 in a billion chance raises philosophical and ethical concerns. Beyond the apocalyptic fears, there are also practical concerns. Funding for high-energy physics research is astronomical, with the LHC costing billions of dollars to build and maintain. Some argue that these resources could be better spent addressing pressing global challenges like climate change, poverty, and healthcare. However, supporters counter that fundamental physics research has historically led to unexpected technological advancements, from quantum mechanics paving the way for modern computing to relativity theory enabling GPS technology. What unknown breakthroughs might emerge from the LHC's findings? What have we discovered so far? Despite concerns, the LHC has already yielded extraordinary scientific discoveries, most notably the confirmation of the Higgs boson in 2012, a finding that completed the standard model of particle physics. Since then, researchers have used the LHC to investigate dark matter, antimatter, and extra dimensions, pushing the boundaries of human understanding. However, many of the biggest mysteries remain unsolved. Dark matter and dark energy. While scientists know that 85% of the universe's mass is made of dark matter, its true nature remains a mystery. Could the LHC finally reveal the particles responsible for this hidden mass? Quantum gravity and extra dimensions. Some theories, including string theory, suggest that the universe may contain hidden dimensions beyond our perception. Could the LHC provide experimental proof? The origin of the universe. By recreating conditions similar to the Big Bang, scientists hope to uncover what really happened in the first moments after the universe's birth. Despite massive progress, each discovery raises more questions than answers. The future of the LHC. What comes next? As the LHC continues its experiments, CERN is already planning the next generation of particle accelerators. One such project is the Future Circular Collider, FCC, an even larger and more powerful successor that could reach energy levels far beyond the LHC's capabilities. However, this raises an even bigger question. Should humanity continue pushing the limits of physics, no matter the potential risks? Some believe that scientific exploration is our destiny, that the pursuit of knowledge should never be constrained by fear. Others caution that reckless curiosity could lead to unintended disaster. In the end, the LHC represents more than just a machine. It embodies our deepest desires to understand reality itself. Anticipated by Hawking's hypothesis of Hawking radiation, some have hypothesized that the LHC's trials could open an entryway to another universe or aspect. In spite of the fact that standard scientists largely dismiss this idea, it has captured the public's imagination, fueling myths and rumors. What lies beyond our universe? Could we accidentally release forces or entities we don't fully understand? The concept of parallel dimensions is not a new one. String theory, a leading candidate for a unified theory of everything, suggests the existence of more than the 4 dimensions we experience, 3 of space and 1 of time. These extra dimensions might be hidden from our senses, but under extreme conditions, they could theoretically be accessed. Imagine the LHC as a key unlocking doors to realms that have remained concealed throughout history. When protons collide at energies never before seen on Earth, they could create ripples that probe these hidden dimensions. While this remains speculative, it highlights the allure of the unknown. The potential of discovering other dimensions continues to captivate the public, even though most scientists remain skeptical that the LHC will open a gateway to another universe, or something far more frightening. Should we be concerned about the risks associated with the LHC? It's easy to get caught up in sensational headlines and fears of cosmic disasters. However, the reality is that scientists at CERN are fully aware of the potential risks and have taken every precaution to ensure the safety of their experiments. They continuously monitor and assess their work with the highest level of diligence. The possible benefits of their research, such as unraveling the mysteries of dark matter, discovering new particles, and expanding our understanding of the universe, are truly remarkable. These breakthroughs represent a significant leap forward in human knowledge. Yet, as with all groundbreaking scientific advances, the experiments conducted at the LHC raise important ethical questions. Could the creation of exotic particles or the exploration of extreme energy conditions lead to unforeseen consequences for our planet or even the very fabric of reality itself? These questions cannot be ignored and must be carefully considered in the broader context of scientific progress. In the end, the Large Hadron Collider is a monumental achievement of human ingenuity and curiosity. It has already led to groundbreaking discoveries in particle physics, shedding light on the fundamental workings of the universe. However, as we explore these unknown frontiers, we must remain vigilant and aware of the potential risks involved. The pursuit of knowledge is one of humanity's most ambitious endeavors, but it is not without challenges. The LHC stands at the forefront of scientific exploration, where theory meets experiment and where the foundations of our understanding of the universe are being tested. The journey of discovery is never without risk, and the LHC is no exception. It pushes the boundaries of physics in an effort to unify the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. However, as we continue to explore these frontiers, we must consider the profound ethical and existential dilemmas that arise from manipulating the forces that govern the universe. The risks of unintended consequences, whether for our planet or the very fabric of space-time itself, remain a challenge that demands thoughtful reflection. Nevertheless, the quest for knowledge remains one of humanity's most noble endeavors. The LHC's experiments, while risky, offer us a glimpse into vast, uncharted realms of science. As we stand on the brink of discovery, we must approach this journey with both ambition and caution. The LHC represents not only the pinnacle of human technological achievement, but also a powerful tool with the potential to reshape our understanding of everything, from subatomic particles to the grandest cosmic phenomena. With each breakthrough, new questions arise, opening fresh avenues for exploration and thought. The path of scientific discovery is uncertain, but it holds the promise of revelations that could redefine our understanding of the universe, our place within it, and the very laws that govern reality. One of the most profound aspects of the LHC's experiments is the convergence of theory and reality. For decades, physicists have struggled to understand the forces that govern the universe: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The ultimate goal has always been to unify these forces into a single, powerful framework, a theory of everything. The LHC has played a crucial role in providing experimental evidence and insights that bring us closer to this elusive goal. Its work not only enhances our understanding of particle physics, but also holds the key to unlocking the fundamental truths of existence itself. The ethical dilemmas tied to these experiments are profound. The pursuit of knowledge has always carried risks, but when those risks involve altering the very fabric of space-time, the stakes become unimaginably high. Could a single experiment at the LHC unintentionally trigger an event we do not fully understand, leading to consequences beyond our ability to predict? This is a question that scientists, philosophers, and ethicists continue to explore. As we delve into these mysterious domains, we must remember the responsibility that comes with wielding such immense power. Despite the potential dangers, few would argue against the pursuit of scientific progress. The rewards, new technologies, medical advancements, and a deeper understanding of the universe are immense. The discoveries made by the LHC so far have already transformed the scientific landscape, from the identification of the Higgs boson to advancements in our understanding of dark matter. These achievements have far-reaching implications, not just for physics, but for multiple disciplines that rely on this fundamental knowledge. As we continue to push the boundaries of possibility, the LHC serves as a reminder that science is never without uncertainty. No experiment is entirely without risk, and the LHC, as grand and powerful as it is no exception. Yet, with every risk comes the potential for incredible discoveries. The LHC symbolizes humanity's relentless pursuit of knowledge, a journey to answer the questions that have puzzled us for centuries. Ultimately, it is this curiosity that drives us forward, the desire to understand the universe, to peer into the depths of existence, and to uncover the forces that govern everything from the smallest particles to the largest galaxies. The LHC may carry risks, but it also represents the pinnacle of human achievement in particle physics. It is a tool that enables us to explore the most profound questions about existence, challenge the very laws of nature, and seek answers to the mysteries that have eluded us for millennia. Whether the LHC will lead to the discovery of new dimensions, open portals to parallel universes, or trigger unforeseen phenomena remains uncertain. What is certain, however, is that it is one of the most powerful scientific instruments ever created, capable of unlocking secrets about the universe that were once thought to be beyond our reach. The potential for discovery is limitless. As we venture further into the unknown, we are reminded that science is a journey, one that requires both courage and responsibility.